Yeah, yeah. All right. Okay. So today, we'll continue our discussion about chain rule and its application and implicit differentiation. Okay. Total differential chain rule. Okay. So hari ini kita akan sambung discussion berkenaan dengan chain rule. Boleh nampak skrin saya ya? Boleh ya? Okay. Alright. Okay, so kita start. Mana yang baru masuk? Assalamualaikum and good morning. Alright. So today we will discuss about chain rule for function of several variables. Okay, so look at this note. Okay, so these are two cases. The first case involves W as a function of X and Y, where X and Y are functions of a single independent variable T as shown in the theorem below. Okay, so this one in chain rule we have two types. Okay, so there are one independent variable and the other one here is two independent variable. So the meaning of one independent variable, it is means that all the function is depend on one variable. Okay, right. So look at this note. Let W is a function of X and Y, where F is a differentiable function of X and Y. If X is a function of T, which is S is G of T, and Y is a function of T, which is Y equal to H of T, where G and H are differentiable function of T when W is differentiable function of T. Okay, and derivative respect to T on W, it is equivalent with a partial derivative respect to X on W multiply with dx dt plus partial derivative respect to Y on W multiply with derivative respect to T on Y. Okay, so this is means that all the function which is W, X and Y are depending on T variable. Okay, so we call T as an independent variable. Okay, so now before we have this formula, okay, so we can form it into tree diagram. Okay, so how to draw a tree diagram? So this one, W is a function of X and Y. So in W, we have two variables, which are X and Y. And in X and Y, we have one variable, which is T. Okay, so this is means that X and Y is depend on T, W is depend on X and Y. So indirectly, W is depend on T also. Okay, so that's why it says that W is a differentiable function of T. Okay, so based on this tree diagram, we can formulate it and we have this one. So the process here is, okay, for the first level, we need to differentiate respect to X on W. And the other side, we need to differentiate respect to Y on W. And we go down, then in this level, we have derivative respect to T on X and derivative respect to T on Y. Okay, so for the first level, we use del because W involves two variables which are X and Y. Okay, and the second level, it is derivative respect to T on X, we use D. Okay, we use D, it is means that we differentiate respect to T on X and Y, where X and Y involve one variable only, which is T. Okay, so this is the notation different between del and D. Okay, so based on this tree diagram, so we formulate it, then we have this one, dw dt, or derivative respect to T on W, it is equivalent with a partial derivative respect to X on W, multiply with derivative respect to T on X, and plus for Y side, which is partial derivative respect to Y on W, multiply with dy dt. So this formula, we call it as a chain rule. Okay, so this one is a chain rule formula. Okay, all right, so for this part, any question? Ada soalan kelas? Can I have any response from the floor?
Faham.
Faham ya? Okay, very good. Okay, so now we look at chain rule which involve two independent variables. Okay, so look at this note or this theorem. So we have W. So W is a function of X and Y. And F is differentiable function of X and Y, where X and Y involve two variables, which are X, S, and T. Okay, S and T. Ini ya. This one. Okay, so based on this information, we can form it into a tree diagram where we have W. In W, we have two variables, which are X and Y. So in X and Y, we have another two variables, which are S and T. So in X, we have S and T, and in Y, we have S and T also. Okay, so based on this tree diagram, we identified that we have two independent variables, which are S and T. Okay, so S and T are independent variable. Okay, independent variable. Okay, so how to formulate the chain rule? Okay, so in the first level yang ini, so we differentiate respect to X and Y on W. So we use a del notation because it is involving differentiation for two variables. Okay, so we have partial derivative respect to X on W, and for this side we have a partial, and I use different color. Taklah, kita guna color yang sama. As long as you faham, okay. Alright, so for this side side yang ini, we differentiate respect to Y on W. And for this level, we have two, which are S and T. So we use del. Okay. So we differentiate respect to S on X. And this side, we differentiate respect to T on S on X also. Okay. And this side, we differentiate respect to S on Y. And we differentiate respect to T on Y. Okay. And then we combine, then we will have a partial derivative respect to T on W and partial derivative respect to S on W. Okay. All right. So it is actually not dw dt. It is del W del T. Okay. Betul kan? Okay. So this is a chain rule formula or application of partial derivative. Okay. We multiply between first level and the second level. Nak kaya ni, then you akan dapat ni lah for the first part. And the second part is a Y side. So we differentiate respect to Y on W, multiply with dy dt. Dy dt. So this one is also del. Del. Yes, del. Banyak typing error ni. Okay, del. Okay, so now we differentiate respect to X on W. Oh, sorry. Terlalu eager sampai tersilap. This one is example 1. I nak explain yang ini sebenarnya. Okay. Right, this one Okay, so based on this tree diagram, we can set ataupun we can formulate the formula for chain rule. For derivative respect to S on W and derivative respect to T on W. Okay, so all notation we use del notation because all the function involve more than one variable. So untuk case yang ini, in this theorem, it is involved two variables which are S and T, and for W we have X and Y. Okay, faham kelas? Ada soalan? Any question? Tak ada Okay, so kalau tak ada, we can go fast. So now we look at this example 1. So example 1, this example involve one independent variable. Okay, so let us see this one. So let W is a function of X and Y, where W here is S squared Y minus Y squared. And we have X and Y here, where X is a sine of T and Y is exponent of T. Right? So the question asks you to find derivative respect to t on w when t equal to 0. So at the end of the day, you will have the value. So answer you akan dapat nilai lah sebab you substitute t into 0. Okay, so first of all, we need to identify the formula. Okay, so based on this example, okay, so kalau you tak ingat formula dia, kita ada solution. You can draw 3 diagram. So based on this, okay, so ini I padam, takut you keliru nanti. Okay, so this one, we have W. In W, we have X and Y. Kita ada X dan juga Y dekat bawah W. Okay, so in X and Y, we have T. Okay, so in X, Y, we have T. Okay, so this means that chain rule ataupun function depend on one variable. So the variable here is t. So all x, y, and w is depend on t. Okay, so now kita tengok untuk first level kat sini kita guna del lah sebab melibatkan two variable. Derivative respect to x on w. Okay, and for this side is a derivative respect to y on w. And we go down, then here we have dx dt. And dy dt because it is involved one variable. Okay, dy dt. Okay, so now we can find derivative respect to t on w by combine left hand side and right hand side. Okay, and for first level and the second level we multiply. Then here we have this formula. Okay, so therefore derivative respect to t on w is del w del x multiplied with ds dt plus del w del y multiplied with dy dt. Okay, so this is a chain rule formula. Okay, so next we need to find the partial derivative respect to x and y on w. So this is our function, which is w. So w is x squared y minus y squared. So we find derivative respect to x. So y remain as a constant. So this one is a partial derivative. So maknanya, bila you nak differentiate x, y akan jadi constant. Alright. So now we differentiate respect to x on x squared y. So differentiate respect to x on x squared y, we have 2xy. And derivative respect to x on y squared. So y remain as a constant. So here we have 0. All right. So therefore, partial derivative respect to x on w is 2xy. Okay. So now we find a partial derivative respect to y on w. So bear in mind when you want to differentiate respect to y, so x remain as a constant. Okay. So now we differentiate respect to y on x squared y. So x squared is a constant. So here we have x squared. And derivative respect to y on y squared, we have negative 2y. So therefore, partial derivative respect to y on w is x squared minus 2y. Right? Okay. So next part we find for this one, dx dt and dy dt. So this one is quite simple. We just differentiate respect to t on x. So our x is sine t. And here we have cosine t. And derivative respect to t on y, we differentiate respect to t on exponent of t. So here we have exponent of t. Okay. So next part, we form all the informations in this formula. Formula yang ni, you masukkan semua. And then you solve. Okay. So now we have derivative respect to t on w is 2 exponent t sine t multiplied with cosine t plus sine squared t minus 2 exponent t multiplied with exponent of t. Okay. Alright, so now we want to find the derivative respect to t on w when t equal to 0. Okay. So this one. Right. So such that t equal to 0. So we substitute all t into 0. At the end of the day, we have this answer, which is negative 2. Right? So therefore, we can say that changes of t on w is negative 2. Right? So any question? So kat sini ada we have about 3 methods. The first method is about partial derivative. Second method we differentiate. Okay, ni method yang kedua. And then method yang ketiga, we apply in chain rule formula. Okay. So, kena ingatlah step dia. Okay. Right, ada soalan? Any question, class? Tak ada ya? Okay, so kalau tak ada, very good. Kalau ada, boleh tanya. Okay, so now look at this example 2. So it is about application of chain rule to related rates. Okay, so inilah one of the application of chain rule. Okay, so actually chain rule we can apply when we have a changes of something. Okay, contohnya you ada perubahan, you nak ubah daripada kotak besar kepada kotak kecil kepada kotak besar. So ada berlaku perubahan, so you boleh gunakan ni lah because it has a related rates between the changes of size of a box. Alright. Okay, so now look at this example. So here we have 2 objects traveling in elliptical paths given by the following parametric equations. Okay, so for the first object, we have x1 4 cosine t and y1 is about 2 sine t. And the second object here is about x2. It is 2 sine t and y2 is about 3 cosine t. Okay, the question asks you to find at what rate is the distance between 2 objects changing when t equal to pi? Okay, so this is your key question, which is you need to find the rate distance between 2 objects. So kat sini ada perkataan distance. So maknanya you kena cari perubahan bagi jarak antara 2 objek tersebut. Okay, and t is changed to pi. Alright. So now look at this diagram. So this is the 2 objects that have mentioned before. We have 2 objects. And the first object, it is about x1 4 cosine t. Okay. And mana objek yang pertama? This one or this one? y1 is 2 sine t. So x1, y1. So x1, y1. It is about at sine t. Sini Okay, this one. So here we have this point is about negative 4, 0. And this one is about berapa nilai dia? You don't know. Let's say katakan yang ini adalah x, 0 to y. Okay. Alright, so now find the SDT. So this is a question. You need to find the rate changes distance at any time t. Okay, so we're changing rate of distance at any time t. Right, so the SDT, this is a formula for the SDT, which is derivative respect to s1 dx multiply with dx1 dt, and then plus the derivative respect to y1 on s multiply with dy1 dt, and then plus with this one and this one. Okay, so this is the formula for changes rate of distance at any time t. Okay, so now we have t equal to pi. So pi, you masukkan pi. So here we have 4 cosine pi equal to negative 4 for x1, and for y1 here is 2 sine pi. Sine pi is 0, so 0 times 2 we have 0. Okay, alright, so this is means that at this point it is about first object lah, negative 4, 0. Okay, objek yang pertama. And then it is travel to this point. So this point is about 0 to 3. 0 to 3. Okay. So, sekarang ni yang nak cari adalah dia punya jarak antara point yang ini ke point yang pertama ke point yang kedua. The question here is how to find this distance. Macam nak cari jarak yang ini. Okay. Right. So, this one, sebelum kita belajar kan, kalau ada perubahan, so maknanya perubahan bagi X dan Y juga berlaku. Okay. So, kat sini, for horizontal, it has a change of X, and for vertical, it has a changes of Y. Okay. Ini changes of Y, and this one is a changes of X. Okay, so now we want to find this distance. So this is about X, Y. So let's say this one is a S, as it is equivalent with square root changes of X power of 2 plus changes of Y to the power of 2. Okay. Alright, so we identify ataupun we have this formula for S, which is square root X squared minus S1 to the power of 2 plus Y squared minus Y1 to the power of 2. Okay, ada soalan tak untuk yang ini? Macam mana kita dapat distance yang ini? Apa kaedah yang kita gunakan? Anyone can answer? Kalau tak ada, saya sebut nama. Nur apa ni? Okay, Anis Zulaika. How do we get this S?
Tak sure lah, madam. Ingat benda ni tapi tak tahu apa nama dia.
Tak tahu apa nama dia. Sekejap. Just. Okay, actually we use theorem Pythagoras. Ingat tak? Kan kita ada segitiga bersudut 90 darjah dekat sini. So katakan kita ada X, Y and Z. So how to find the distance ataupun the length of Z? So X is hypotenuse. Okay. So it is actually Z squared equal to X squared plus Y squared. Betul? So Z equal to square root X squared plus Y squared. So the relationship between this theorem and this one, okay, this case, in this case we want to find the distance. Kita nak cari jarak. Jadi bila cari jarak, you kena cari dia punya apa panjang dia lah, length dia. Okay, so now we have this. It's look like triangle with 90 degrees. So we can apply theorem Pythagoras in this case. Okay. Alright. So the difference here is along X we have changes of X, which is S2 minus S1. Dia ada berlaku perubahan antara point yang ini ke point ini. Di mana dia travel kan daripada point ini ke sini, dia bergerak. Jadi berlaku perubahan bagi X dan juga Y. So that is why we have this formula for distance, which is square root X squared minus Y, X2 minus S1 to the power of 2 plus Y2 minus 1 to the power of 2. Okay, jelas? Boleh faham semua?
Jelas.
Zulaika, okay? Boleh faham? Dah ingat dah? Dah ingat balik dah?
Boleh. Ingat.
Okay, good. Okay, alright. So next we find the derivative respect to X and Y on the S. Okay, so S1 on S. So this is our S. Square root S squared minus S1 to the power of 2 plus this one. And then we differentiate respect to X1. So the rest constant. Kita fokus pada S1 sendiri. Okay, so here we have negative S squared minus S1 over square root S squared minus S1 squared plus Y squared minus Y1, Y2 minus Y1 squared. Okay, so next you just enter the values. S1 is negative 4, S2 0, and so on. So you masukkan, and here we have derivative respect to S1 on S is negative 4 over 5. Okay, and we repeat the same procedure, which is we differentiate respect to Y1 on S. and we enter all the values that we have obtained from the above, then here we have -3/5. Okay, so next part, x2 on s, derivative respect to x2 on s, we have 4/5. Sorry, and the last one we have 3/5. Okay. Okay, so apa lagi yang you kena cari? This one, ada benda banyak yang nak cari kat sini. It is about 8 information. Ni yang pertama, yang kedua, ketiga, keempat. So next you need to find derivative respect to t of x1, y1, x2, y2. Okay, so you just differentiate and you enter t equal to pi, and then you will have the value kat sini. Okay, so lastly you just form it into the formula. You masukkan dalam formula and we have this value. So therefore, the distance ataupun the rate changes of distance at any time t is 22/5. Okay, boleh? Itulah kadar perubahan bagi distance pada bila-bila masa. Alright. This one. Okay, ada soalan tak?
Madam,
Any question?
Explain bahagian generalizing tu.
Yang mana? Ni.
Yang yang semua tu.
Right. So ini kita differentiate respect to S1 on S. So I explain this one. Okay, so yang ini you just differentiate respect to S1 on S. So we have this S. Okay, so bila nak differentiate yang ini, sana saya buat satu kat whiteboard. Okay. Right. Kita tadi apa? S is a square root x2 minus s1 and then plus y2 minus y1 square root. Okay, so now we want to find derivative respect to x1 on s. Nampak tak?
Ada kuasa 2 Madam.
Ada kuasa 2, ya, betul. Okay, so it is also equivalent with x2 minus s1 to the power of 2 plus y2 minus y1 to the power of 2 and the whole thing to the power of 1/2. Okay, so now we want to find the derivative respect to x1 on s and the rest is it will be the constant. So s2 dia akan jadi constant, y2 constant, y1 is also constant. Okay. So now we want to differentiate for this one. Okay, so as you know, for derivative ataupun differentiation, the power kat sini dia akan jadi multiplication. So here we have 1/2. Okay, so 1/2 times x squared minus s1 squared plus y2 minus y1 squared. And the power here is negative 1/2 minus 1. Okay, so we differentiate dengan jadi 1/2 minus 1. Then here we have a negative 1/2. And then multiply with this one. Derivative respect to x2 minus s1. So yang ini you differentiate dapat kosong. Okay, so don't worry this one. So instead you need to differentiate respect to s2 minus s1 squared plus y2 minus 1 y1 squared. So differentiate yang ini. And here we have kat sini ada kuasa 2 kan? Okay, I tulis kat sini lah differentiate del x1 for x2 minus s1 squared plus y2 minus y1 squared. Okay, kita differentiate ni. So ini dapat 1/2 x squared minus s1 squared plus y2 minus y1 squared to the power of negative over 1 and multiply with this one. So multiply with this one. So multiply yang ni dapat 2 times s squared minus s1. So this one it will be 0 because it is constant. And then inside here we have this function. You multiply, differentiate, and here we have negative 1. Okay, so here we have negative 2 times s squared minus s1. Alright, and then over, so since we have a negative power, so maknanya dia berada di bawah lah, which is a denominator. Sekejap, wait. Besar pula dia. Nampak kan?
Nampak.
Tak boleh atas. Okay. Right. So over. Yang ni kita ada 1 over 2 square root x squared minus s1 squared and then plus y squared minus y1 squared. Okay. So this one 2 times negative 1 we have negative 2. So this one we can simplify. Then here we have negative x2 minus s1 over square root x squared minus s1 squared plus y2 minus y1 squared. Okay, so this is our derivative respect to s1 on s. Jelas?
Jelas.
Okay, yang lain okay? Ada soalan? Tak ada. So untuk x derivative respect to s2 on s, y2 on s and y1 on s is macam ni lah, sama. Cuma bila kita nak differentiate respect to x2, so the rest we take it as a constant. Okay, faham Okay, any question? Ada soalan lagi untuk part yang ini? Okay, so that's why we have this answer. So you just enter the value because we have the equal to pi. Yes.
Dalam kerja tadi tu kena tunjuk ke dalam exam?
Kena.
Okay.
Alright. Okay, so this one you need to show in your answer workout. Okay, in working out you kena tunjuk lah. Sebab this one is a method for partial derivative. So yang ini adalah part partial derivative. Yang itu wajib sebab dalam chain rule it is an application of partial derivative. And then this one is about differentiation biasa lah, differentiation. And we have another method. So this is a chain rule method. Okay, so kita ada 3. Alright, so again in chain rule we have a 3 step. First you need to differentiate, you need to apply partial derivative. Second step you need to differentiate. So untuk yang ini tengoklah kalau you punya variable depend on the independent variable is 1, so we use different biasa, differentiation. Okay. If it is involve 2 independent variables, then you need to apply partial derivative. Okay, tepat yang ini. Alright, and then last one you apply chain rule. Okay, so this is a one application of chain rule. Okay, ada soalan? Tak ada. Okay, kalau tak ada kita tengok ni example 3. Example 3 it is about finding partial derivative by substitution. Okay, so this one we do not apply chain rule method. We just use substitution. Okay, so look at this example. In this example, it asks us to find partial derivative respect to s on w and partial derivative respect to t on w. For w is 2sy, where s is s squared plus t squared and y is s over t. Okay, so based on this case, we identified that it has 2 independent variables which are s and t. So kalau you now form into 3 diagram, so in w you tengok kat situ w ada 2 variable x and y, And in X and Y, we have another two variables, which are S and T. So here we can say that these functions involve two independent variables. Okay, so the variables are S and T. Okay, so in this example, it is shown about, ataupun it is shown, we find a partial derivative by substitution, where we substitute X and Y into S and T. Okay, so maknanya dekat sini, dia direct gantikan X and Y ke dalam sebutan S dan juga T. So in W, since we have 2SY, in S and T we have 2S squared over T plus 2ST. Okay, faham So ini X, yang ini Y, digantikan. And then we find the derivative or partial derivative respect to S on W. We differentiate respect to S on W. Then here we have 6S squared over T plus 2T. And derivative respect to T on W, we differentiate respect to T on W. This one is T. So S remains as a constant. Then here we have this answer. Okay. So this one kita guna substitution. We substitute X and Y into S and T. And in this example, example 4, dalam example 4 ni, we apply chain rule, which involve two independent variable. Okay. So this is the diagram. So we use this formula, del W del S equivalent with this one, del W del T equivalent with this one. And then we differentiate each of it, partial derivative respect to X and Y on W. So here we have 2Y to X. And the partial derivative respect to S on X and Y also. And partial derivative respect to T on X and Y. Okay, and then you form it into the formula. This formula yang pertama, kita apply formula yang pertama. And the second, we apply in the second formula. And we have this answer. Jawapan dia sama, cuma kaedah dia berbeza. Okay. Ya, yang atas tu kita guna substitute. Kita substitute je X and Y into S and T. But in example 4, we apply chain rule. Okay, ada soalan? So, kalau soalan tu minta use chain rule, then you have to use chain rule. You kena guna chain rule lah. Kalau dia tak cakap apa-apa, dia kata find the partial derivative respect to S and T on W, then you can use any method. So be careful. Kalau dia minta, kalau soalan minta untuk you gunakan chain rule, then you have to use chain rule. If you give this answer, katakan you guna method yang lain, there is no mark at all. Tak ada markah langsung. Because you are not answer the question. Tu reason dia. Okay, so ada soalan? Untuk example 3 and 4. Any question? Tak ada? Betul ni?
Ada.
Okay, very good. Okay, so now the chain rule for a function of three variables. Tadi 2 variables, so now we have 3 variables. So we need to find partial derivative respect to S on W and T on W. When S equals to 1, T equals to 2 pi for W. So this is our function. X, Y plus YZ plus XZ. Where X, Y, and Z depend on S and T. Okay. So now, kalau in tree diagram, we will have W. So in W, we have 3 variables, X, Y, and Z. And in X, Y, and Z, we have 2 variables. So to X, we have 2 variables, S and T. Y, S, and T, and Z is T. Okay, so this is means that all the functions is depending on S and T. So S and T are independent variables. Okay, right. So how to formulate chain rule for this case? So macam biasalah, you differentiate. For the first level, we differentiate respect to X, Y, and Z on W. Kat sini, y on w, and the last one, differentiate respect to z on w. And the next level, we differentiate respect to s on x, and we differentiate respect to t on s. And in the middle side here, we differentiate respect to s on y, and we differentiate respect to t on y. And the last one, we differentiate respect to t on z. Okay, right, so this is the formula. So bila nak cari derivative respect to z, so we concern on the derivative respect to z pula. Derivative respect to s, so we concern on the derivative respect to s. So you focus pada s kat sini lah. Kalau nak cari derivative respect to t, so we focus on the t variables. This one. Okay. Untuk for the first level ni, semua kena you need to apply. Alright, so now look at this example. So differentiate respect to x on w. So we have this function. So you differentiate respect to x, so y and z remain as a constant. Okay, so differentiate respect to s on sy, we have y. Differentiate respect to x on yz, so yz is a constant, then we have 0. And derivative respect to x on xz, we have z. So derivative respect to x on w is about y plus z. Okay, so it is similar for this one. To differentiate respect to y on w, so x and z remain as a constant, then here we have x plus z. Untuk z pun sama, so bila nak differentiate respect to z, x and y remain as a constant, then we have y plus z. Okay. So next part, we differentiate respect to s on x, y, z, and the other one, we differentiate respect to t on x, y, and z. Okay. Ni typing error y, this one is z. Alright, and next part, the last method. We apply ataupun we enter all the informations that we have obtained in the formula. Then here we have this answer. For derivative respect to s on w is about 2 pi, and derivative respect to t on w it is about 1 plus 2 pi. Okay, any question? Class boring ke? Okay, so that's all about chain rule. Okay, ada soalan?
InsyaAllah tak ada.
Tak ada. Okay, very good. Okay, I'd like sikit je. Implicit differentiation. This is a very simple one. Okay. Okay, so simple. Okay, so implicit partial differentiation. Yang tadi tu adalah chain rule. So this one is about implicit. So implicit partial differentiation, it is also an application of partial derivative. Okay, right? So it is an application of chain rule to determine the derivative of a function defined implicitly and defined in the theorem below. Okay, so look at this one. So chain rule, implicit differentiation. So if the equation f(xy) equal to 0, so defines y implicitly as a differentiable function of x, then dy dx, it is equivalent with negative derivative respect to x on f over derivative respect to y on f, where f derivative respect to y on f does not equal to 0. Okay, so untuk yang ni, you have to set up the function equal to 0. And then we differentiate respect to x on f and over derivative respect to y on f. So this is the formula for implicit differentiation. Okay, right, so next, if the equation f, where f is a function of x, y, and z equal to 0, so define z implicitly as a differentiable function of x and y. Then here we have del z del x equivalent with negative derivative respect to x on f over derivative respect to z on f. Okay, and for del z del y, the formula in implicit differentiation is derivative respect to y on f over derivative respect to z on f, where derivative respect to z on f does not equal to 0. So this is the condition where we know all the denominator cannot be equal to 0. Okay? Faham tak? Implicit differentiation ni, you just apply this formula. Okay. Okay, any question for this part? Tak ada eh? So kalau tak ada, very, very good. So we look at this example. Example 6, find a derivative implicitly. So bila soalan minta find a derivative implicitly, then you need to apply implicit differentiation. Okay. So the question asks you to find dy dx for y to the power of 3 plus y squared plus 5y minus x squared plus 4 equal to 0. Okay. So first of all, we need to declare f. Okay. We need to declare f, which is f xy equal to 0. So let our f here is y cubed plus y squared minus 5y minus x squared plus 4 equal to 0. And then we apply implicit differentiation for dy dx as this one. So this is a formula for dy dx in implicit differentiation, which is negative derivative respect to x of on f over derivative respect to y on f. Okay, so you differentiate for numerator and denominator. At the end of the day, we have this answer. Therefore, dy dx by using implicit differentiation is 2x over 3y squared plus 2y minus 5. Okay? Boleh? Any question? Tak ada. Very good. So, this sama juga. Finding partial derivative implicitly. So, we apply partial derivative in implicitly. So, we have this formula. Okay, so first we declare for f. So, this one, this is one method. So, you perlu tulis macam ni. So, you have to declare for f. And then apply in the formula. And we have this answer. Okay, ada soalan? Tak ada eh? Kalau tak ada, good. So, buat exercise sikit. AQPS. Sekejap ya. Oh.
Madam,
Yes.
bila nak guna formula ni, madam?
Bila nak guna formula ni, this one.
Oh, yang implicit ni.
Oh, kat mana kita boleh apply, is it? Okay, so for this formula, we can apply in dalam in the change rate of changes. Okay, so let's say we have the surface, and then you nak cari dia punya changes, then we can apply this implicit differentiation. So this one, implicit differentiation, it is actually one of application in chain rule. Okay, so kalau chain rule tu kita guna yang tadi tu formula tersebut. Instead of that one, we also can use this one. Okay, kita juga boleh gunakan yang ini. Alright. So kat mana you apply? You can apply in real world. You can apply in any subject which involving rate of changes, pertukaran bagi sesuatu kadar. Jadi you boleh gunakan yang ini juga lah selain daripada chain rule. Okay. Boleh?
Okay, madam.
Jelas? Am I answer your question?
Jelas.
Okay. So untuk further information, you also can read textbooks. Kat situ pun ada terangkan kat mana you boleh apply benda ni. Alright? Okay. Any other question? Tak ada. Okay. Alright, so as a conclusion, first tadi sebelum ni kita dah discuss partial derivative. Okay, so partial derivative yang kita discuss sebelum ni, how do we solve the problem which involving differentiation yang melibatkan lebih daripada satu variable. So the method to solve that one, we need to use partial derivative. So partial derivative means that we differentiate respect to x or y on the function which involve more than one variable. So means that kalau you nak differentiate respect to x, so y itu akan jadi constant. Katakan you nak differentiate respect to y, so x akan jadi constant. Maknanya kita fokus kepada apa yang kita nak differentiate. Itu satu untuk partial differentiation. And then kat mana kita boleh apply partial differentiation? In a partial differentiation, we can apply in a total differential. Macam sebelum ni kita discuss untuk total differential, kita nak mencari difference ataupun kita nak gunakan difference untuk mencari nilai yang berhampiran estimation value ataupun approximation value. So kat situ kita gunakan partial derivative. Okay, and another thing, selain daripada total differential, we also use partial derivative in chain rule. Banyak kita guna dekat chain rule juga. Ada juga kita gunakan di dalam chain rule. And the other one is the implicit differentiation. So implicit differentiation, it is a application of partial derivative. Okay. So kat sini sama jugalah, kita dah tahu dah. Bila kita boleh gunakan chain rule. Kita boleh gunakan chain rule apabila ia melibatkan function yang berangkai. Okay, contohnya sebelum ni kita ada function x dan juga y. Okay. Alright, so this one, mana contoh di atas tadi tu, kita tengok kepada definition. Okay, so we have this function which involve x and y. Tetapi x and y itu depending kepada variable yang lain. Contohnya t. Okay, they depend pada one variable. So kat situ berlaku satu network. Okay, in W we have x and y. In x and y we have another variable which is t. Dia boleh juga jadi ni you nampak dua level. Boleh juga jadi tiga level which is t depend on the other variable. Boleh juga. Rule ini kita panggil sebagai chain rule. Iaitu rule yang berangkaian. Rantaian lah. Okay, tu chain rule. Okay, so maknanya dekat sini, kalau satu case ataupun you have a problem which involve function x and y and then yang itu dia bergantung kepada function yang lain ataupun bergantung kepada variable yang lain, then you can use chain rule to solve the problem. Okay? Jelas Untuk implicit differentiation pula, it is a small ataupun a simple method that we can apply in chain rule. Macam tu. Okay. Jelas Tetapi untuk differentiation, dia different dengan chain rule tu sebab untuk implicit ni, function yang terlibat adalah the function itself which is f. And the function must be equal to 0. You kena set dia sebagai kosong. Then you can apply. So kalau biasanya, untuk yang biasa yang belajar dy dx apa semua tu, so function dia akan melibatkan, for example, melibatkan satu variable saja, iaitu katakan we have to x plus 1. And then you just differentiate df dx. Then we have 2 here. Okay, so beza dengan yang ini, dalam function ini melibatkan lebih daripada satu variable. Okay, lebih daripada satu variable. It can be x, y, z ataupun it also can be x, y and so on. Tetapi kita nak fokus kepada changes of x on y. Macam mana kita nak fokus kepada y, changes of x on y? Sedangkan function ni melibatkan banyak variable dekat situ. Okay, so in order to handle this problem, so implicit partial differentiation comes in. So ada satu formula untuk memudahkan kita differentiate ataupun mencari perubahan kadar perubahan pada kadar perubahan bagi X kepada ataupun ke atas Y. Macam tu. Jelas faham tak? Tak faham saya ulang lagi. Usna, faham tak? Mana Usna ni? Usna?
Ya, saya.
Okay. Any question?
No.
Okay, very good. Okay. So that is about partial derivative. Apa tu? Total differential, chain rule dan juga tadi apalah sekali implicit differentiation. Okay, so kalau tak ada soalan, cuba kita jawab soalan ni. Ya, sihat ya? Saya sekarang tengah mengalami batuk dan sesama. Okay, right. Tiba-tiba dah buka pula ni question 6. Okay, so try buat soalan. Yang ni total differential. Soalan 5, soalan 6. So this one. Okay, so question 6 ni you boleh buat. Try buat sendiri sebab ini proving. So you have to show left hand side equal to right hand side. You have to show this one. Betul. Okay. So we have this function. So fxy equal to x plus y times exponent sy. So now you need to show that second order partial derivative respect to s on f plus second order derivative respect to y on f equivalent with this one. Okay. Boleh buat, try buat question 6 ni. Okay, so next look at question 7. So question 7, it is about chain rule. Okay, so use chain rule to find derivative, partial derivative respect to t on z when s equal to 0, t equals to 1. For z is exponent sy tangent y, where x equal to s plus 2t and y equal to s over t. Okay, so kita try buat ni question 7. Question 7. Mana soalan ni? Okay, so find del z del t. Okay, so s is 0, t equals to 1. And z exponent sy tangent y. X s plus 2t. Lagi satu apa? Y s over t. So y equal to s over t. The question asks you to use chain rule. So first you need to identify for a formula ataupun for the chain rule method. Okay, you identify that one. So now, okay, so find del z del t. So del z del t. So kalau tak nak buat ni dulu, you boleh buat tree diagram. Okay, so we have z. So z, in z we have x and y. Okay, so in x and y we have another two variables, s and t. Okay, so from this tree diagram, we identified that we have two independent variables, which are s and t. Okay, so now del z del t. Del Z del T, it is equivalent with partial derivative respect to x on Z multiply with del X del T, and then plus with the partial derivative respect to Y on Z multiply with del Y del T. Okay. Alright, so this is a formula for derivative respect to T on Z. So next, apa nak kena buat? We need to differentiate respect to X. This one, kita cek ini. Okay, so try buat sama-sama. Try, kita buat sama-sama. Kita cari del Z del X. Okay, so we differentiate respect to Z or respect to S on Z. So Z is exponent of XY multiply with tangent of Y. So nak differentiate respect to X, Y remain as a constant. Okay, so now we have exponent SY. So differentiate this one, we have exponent SY and we have another function here which is SY. So we differentiate respect to X on XY, then we have Y here. Tangent Y tak perlu usik lah sebab dia adalah constant. Okay, so here we have derivative respect to X on Z. It is about Y, exponent XY, tangent Y. Okay, so next, del Z, del Y. So we differentiate respect to Y on Z. So Z is exponent XY. Sorry, so this one we use product rule because it is involving two functions, multiplication between two functions, exponent and tangent Y. So ini you guna product rule. So first we differentiate respect to Y on exponent XY. So here we have X exponent SY times tangent Y and then plus with tangent exponent of Y, exponent SY. Differentiate tangent, we have secant squared Y. Okay. So next we find the partial derivative respect to T on X. Okay, so differentiate respect to Sun, bisa cek mana ni? Sekejap. Main balik dia. Okay. So kita cari derivative respect to T on X. X kita adalah, apa tadi X kita? Boleh buat korang? Oh. S plus 2T. Differentiate respect to T on X, so we have a 2 here. And then derivative respect to, apa lagi yang diperlukan? Respect to T on Y, so we differentiate respect to T on Y, so our Y here is S over T, betul? S over T. Negative S over T squared. And then you masukkan semua dalam formula yang ini. Okay. Alright. Okay, so untuk cari nilai X dan juga Y tu, you boleh masukkan nilai S kosong, T sama juga dengan 1. So, you akan dapat apa nilai X tu. So, X equals to, S equal to 0, T 1. So, we have 2. And Y sama juga dengan 0/1. 0/1 is 0. Okay, masukkan sahaja. Exponent, di mana ni jawapan dia? Y0. Exponent 2 times 0 is 0. Tangent 0, so jawapan dia kosong kat sini. And this one, you masukkan je nilai dia. And we have 2. Tangent 0 is 0 kan? Betul tak? Secant squared y, so secant 0, 1 over cosine 0. Cosine 0 is 1 lah, so 1. Exponent plus 1 dekat sini, then we have 1 here. Double check ya. Okay, so untuk yang ini pun you dapat nilai negative as 0. This one is also 0. So now our del z del t, it is equivalent with del z del x. 0 times del x del t is 0. Double check kalau silap ni gitu. Del z del y is 1 times dy dt. Mana dy dt? 0 ke jawapan dia? So the answer is 0. Double check ya kalau ada kesilapan bagi tahu. Okey kelas, boleh ada soalan?
Tak ada,
Senyap
madam.
je ni. Tak ada. Okey ya. Alright.